Hello, my dear students. Once again, welcome to your online class. So today in this video, we'll be learning the 11th chapter of your physics textbook, that is the chapter Calorimetry. So we have already studied about heat in the lower classes, and we have also already learned about the temperature. So we know that the heat is a form of energy, and the temperature is the hotness or the coldness of a body. So we had studied in the lower classes that the temperature can easily be measured by the help of the device known as a thermometer. But heat cannot be directly measured by any of the device. So heat is indirectly measured by the principle of calorimetry, in which we use a special kind of vessel which is known as calorimeter. But however, the details discussion on this calorimeter is excluded in your reduced syllabus. So we will be just taking few of the topics in this chapter. That is, we'll be discussing about heat and its unit. We'll be discussing what is the specific heat capacity. We'll be learning about the principle of mixture, the change of state, heating curve for the water, specific latent heat, and finally some common examples related to the latent heat. So coming to the first topic, that is heat. So what is a heat? We have learned that the heat is a form of energy. Now which form of energy? Okay, what causes the body to get heated up? So to understand that, we have to go back to the molecular theory or the kinetic theory of the matters. So we know that all the matters, they are made up of a small particle known as atoms or molecules. And in the second postulate, we had also learned that these motions, they are always in the state of random motion. And in the third, we had already studied that with the increase in the temperature, the molecular motion also increases. So thus what happens is when we supply a heat energy to the body, its motion increases. Okay, suppose now if a body has a number of molecules, okay, so when it is heated, when the heat energy is supplied, what happens? There is an increase in the velocity of each of these particles. Okay, so and we already know that whenever a body is in motion, it possesses the energy known as the kinetic energy. Okay, so here each of these molecules, it possesses a kinetic energy due to its state of motion. So now if I sum up the kinetic energy of all of these molecules, that is said to be the heat now. So what is heat? Heat is the measure of internal energy of a particle. Okay, so that means summing of the kinetic energy of all the moving particles of a given matter, that gives the measure of heat. So thus we can say that the heat is the measure of internal energy of a body. Okay, so now it must be clear to you that what is heat, the concept of heat. Okay, so it's nothing much, just the summing of the kinetic energy of all the molecules is said to be the heat energy. Now, since this heat is also a physical quantity, so heat can easily be measured. But however, there are various units to measure heat. So the first unit to measure the heat is joule. Since the heat is also equivalent to the energy, and the energy's unit is joule, which we have already in the second chapter of your physics. So the SI unit of heat is taken to be joule. Okay, so discussing about the units, we have the SI unit as joule. Okay, so joule is the SI unit of heat. But however, the most commonly used unit of heat is calorie, which can be written as CL, okay, or simply or C. Or, so now coming to how much energy is known as a 1 calorie. So now the 1 calorie can be defined as it is the amount of heat energy required to rise the temperature of 1 gram of water by 1 degree centigrade. So if you take 1 gram of water at 8 degree centigrade, suppose initially the 1 gram of water is at 8 degree centigrade. So in order to make it 9 degree centigrade, you have to supply some amount of heat. So that amount of heat is said to be 1 calorie. But it is noticed that the heat absorbed by the water at different temperature is not constant. Okay, till 14.5 degrees centigrade, the heat energy absorbed by the water for 1 degree rise of temperature is not constant. So that's why more precisely we can say that the heat energy, or sorry, the 1 calorie is the heat energy required to rise the temperature of 1 gram of water from 14.5 degree to 15.5 degree centigrade, which also measures 1 degree. Why we mention 14.5 and 15.5? Because the heat energy absorbed by the water to rise its temperature by 1 degree centigrade after 14.5 degrees centigrade is constant. So that's why we mention this temperature while defining the 1 calorie. Now comes the question, since both are the units of heat, so what is the relation between a joule and a calorie? So it's very simple. 1 calorie is approximately equals to 4.2 joule. Okay, so this is very necessary to solve some of the numerical problems. So 1 calorie is almost equal to 4.2 joules, which is a rounded off value. So now coming to the next topic, the specific heat capacity. So you must have observed that in our day-to-day life, the different substances, it absorbs different amount of heat to rise the temperature by same amount. Like for example, if you take a wood and if you take an iron rod and if you put it in a water, not sorry, water, in a fire for a short period of time and you pull it out, which one will be more hotter? Obviously, the iron will be more hotter than the wood. Or you can take some other examples like heating of a water or and heating of a milk. Okay, so when you heat both the substances on the same source of heat for the same period of time, you'll see that the one will be hotter than the other one. Okay, so it is very clear that different bodies absorbs different amount of heat to rise its temperature by same amount. So that is said to be the heat capacity. Okay, so we'll come what is specific heat capacity after we discuss about the heat capacity. So the heat capacity C dash, C dash is the symbol used for heat capacity. So it is equal to the amount of heat energy absorbed per degree rise in temperature. So del T, where del T is the rise in temperature. Okay, so you have a certain amount of object or a matter, and then you want to rise its temperature by a certain amount. So whatever amount of heat is absorbed, okay, that divided by the rise in temperature is the heat capacity. Now, when it comes to rise the temperature of a unit mass of a substance, then that is said to be the specific heat capacity. Okay, so you may simply write as C is equals to Q divided by del T divided by M. Okay, so this is for the per unit mass. So from this, we can also calculate the heat energy absorbed by the body for the rise in the given amount of temperature. When we cross multiply, we can simply write Q is equals to del T M C. Okay, so this is the formula to calculate the heat energy absorbed by the body of mass M and for the rise of temperature del T. Okay, so it's very easy to remember this expression Q is equals to del T M C. You can remember it as TMC, the Trinamool Congress. Okay, so it's very simple. So that is what is known as the specific heat capacity. So now coming to the unit of specific heat capacity, we can easily discuss from this formula. So the what is the unit of temperature? The temperature is degree, centigrade or Kelvin. Mass is taken to be kg. Okay, and C. Okay, so sorry, we will discuss the unit of specific heat capacity. What is the SI unit of heat? It is joule, or you can take calorie also. So joule per degree per kg is the SI unit of specific heat capacity. Okay, or you can also write it as calorie. Okay, so it is the heat, it is calorie per degree centigrade per kg. Okay, so any you can take. So that is how we find the SI unit of specific heat capacity of a given substance. Now coming to the third topic, the principle of mixture. So what does the principle of mixture says? The principle of mixture says that the heat energy lost by the hotter body will always be equal to the heat energy gained by the colder body. It's from our day-to-day experience that when we keep two bodies in contact, one hot and the other cold, what happens? The hotter body, it starts becoming colder, and the colder, it starts becoming hotter. Okay, so that is what is the principle of mixture. So the heat gained by the cold body will be equal to the heat lost by the hotter body. So using this principle, we can find out the specific heat capacity of a given substance. So we'll do some of the numericals related to the principle of mixture. Now coming to the fourth topic, the change of state. Okay, so what is the change of state? We know that like whenever the heat energy is supplied or the heat energy is absorbed, it is seen that the body changes its state. Okay, so we have three states. One is the solid. The solid can change into the liquid, and then further it can change into the gas. Okay, so we have different terms when the change of state occurs. When the solid changes to liquid, it is called melting. When the liquid changes to gas, it's called boiling. When the gas changes back to the liquid, it's known as condensation. And when the liquid changes back to the solid, that is known as solidification. Now, there is also the direct process in which the solid changes into the gaseous state without passing to the liquid state, and that is known as sublimation. And the gas can be condensed or changed, condensed into the or solidified directly into the solid without passing to the liquid state, and that is known as deposition, which you have learned in your lower classes also. But now it is observed that when there is a change of state, there is no rise or fall of temperature. Okay, like what it means is like if you take ice cubes. Okay, so when I take an ice cube which is at minus 7 degrees centigrade. Now, if I want to change it into a water, what do? I supply a constant heat. So on heating, what happens to the temperature? It will start increasing. Minus 7, it will become minus 6, minus 5, minus 4, minus 3, minus 2, minus 1, and finally 0. And we know that at 0 degree centigrade, the ice starts melting. Now, when the melting starts, the temperature will remain constant, 0 degree centigrade only. Okay, though we are supplying heat, but there will be no rise in temperature until whole of the ice will change back into the liquid. That means when there is a change of state, the solid changing into the liquid or the liquid changing into the gas, there is no rise or fall of temperature. Fall of temperature in the sense when the gas changes to liquid and the liquid changes to solid. So in that change of state, there is no rise or fall of temperature. Then where is the heat going? The heat energy is absorbed or utilized in changing the molecular structure or the formation of the molecules in the different states. So now whatever amount of heat energy is absorbed or evolved, that is said to be the latent heat. Okay, and then when we take it for a unit mass, it is known as specific latent heat. So that is what is meant by the specific latent heat. So now we'll also be discussing about the heating curve for the water. Okay, so if I draw the curve for the water, okay, so what happens? So with this axis, it represents the time. Okay, and suppose if this axis represents the temperature. Okay, so now if I take ice, suppose the ice is at minus 2 degrees centigrade. So with the time, when I start heating, the temperature starts rising. Okay, and then at 0 degrees centigrade, what happens? The melting occurs. Now, when the melting occurs, the temperature will remain constant. Now, once all the ice changes into the water, the temperature starts rising again. Okay, where it will rise up to 100 degree centigrade. So now at 100 degree centigrade, what happens? The liquid or the water, it starts changing into the vapor. So at that also the temperature remains constant. And then there will be a rise in the temperature of the vapor. Okay, so these states represents melting. This represents the rise in temperature and this represents the boiling. Okay, so you should be able to find out which part of the curve represents the change of state. Now coming to the final, some of the common examples of the latent heat. So there, like we see that the latent heat, okay, like the best example for the latent heat will be the like the boiling of water and the vapor. Okay, so the vapor, what happens? So when the water changes into the vapor, so during the change of state, the vapor it absorbs more amount of heat. That means if we have a water at 100 degrees centigrade and a steam at 100 degrees centigrade, okay, so the steam contains more amount of heat than the water. So that's why the steam, it causes more harm to your skin. It causes a blister. But you can plunge your hand into the 100 degree centigrade of boiling water and cool it immediately. But if you try it same with the steam, like if you have a steam, just put your hand on the steam for 1 second, it may burn your hand. Okay, so that is one of the examples of the latent heat of substances. Okay, so there are many examples in your book, so which you may learn, and then there are many solved examples as well and the numericals which you may try, and if Any problem exists, you are free to contact in my WhatsApp number. Thank you.